All right, guys. What I want to do is start talking about the next chapter. Once again, we may go through this one relatively quickly as well because your calculator can do so much of it. But we'll start a little bit. In each of these, I'm going to explain what they mean and how you solve it by hand. But once again, and as far as what you will be expected to do on quizzes and tests is to know how your calculator can help you solve these quickly. Okay, first of all, just a review. We're going to talk about multiplication properties of exponents. So let's talk about an exponent and review that. Okay, when you're looking at this exponent, okay, if you hear the way that I'll refer to things, this number I'll often refer to as the base, and this number I'll often refer to as a power. And the whole thing itself I'll refer to as the exponent. And so oftentimes you'll hear the term exponent to represent this power, but I try to separate it and be distinct about what I'm talking about. And so this exponent has a base of 4 and a power of 3. Does that make sense? Okay, as far as exponents themselves represent what operation? 4 to the third means what? You're taking 4 and doing what?
4 times 4 times 4.
Good. Exponents are just repeated multiplication, right? So 4 cubed is really 4 times 4 times 4. Okay, so what if I gave you 4 to the 5th? What does that equal?
4 times itself 5 times.
Okay, so it's the base times itself. The number of times is the power. Okay, so again, that's just a quick review of what an exponent is. Okay, so what do you think is going to happen if you multiply these? So if I took 4 cubed times 4 to the 5th, if I were to expand these out in this repeated multiplication form, I have 4 cubed, which is 4 times 4 times 4. And then I'm multiplying that by 4 to the 5th, which is 4 times 4 times 4 times 4 times 4. So when I write my answer for this, I can take this common base of 4. And how many times is this base being multiplied by itself total now? So here's 3 of them. And here's 5 more. So we have a total of 8. So what did we do to the powers when we multiplied exponents? We added them. So this is the process. Anytime you multiply exponents with the same base, you add their powers. So I just use all the terms that I separated here. And does everybody follow that? Anytime you multiply exponents with the same base, so 5 squared times 5 to the 7th. Okay. Exponents, they're written with a base and a power. They have the same base, 5. So what are we going to do with their powers? Add them. So we keep the same common base, and we add their powers. Okay. And then that whole process you can do mentally. You get your answer of 5 to the 9th. All right, let's say you had something like this. Y to the 4th times y cubed is equal to what? Common base y to the power of 7. Add their powers, and you get your total. Okay. So it works for variables as well as numbers. Okay. What if I gave you something like this? What's that going to equal? James? Now, careful. Okay, so you have 2. You have 2 common bases. Okay, so we're going to repeat that base. We just write that common base down. And then, since we're multiplying, Lauren? Good. Negative x, and then add the powers. Remember, anytime there's nothing written, it's an unwritten 1 for the power. Okay, so you have 1 plus 2 gives you 3. Okay, and so you would write your answer at this time as the quantity, the base negative x, to the power of 3. Okay, are there questions about this property? The general rule for this property is the following. If you have a to the m times a to the n, okay, so two exponents with the same base, you're going to add their powers. Okay, so this is referred to as the product of powers. Rule. Okay, now there's also a rule that says if you take a power to a power. Okay, so let's take a look at what happens if we take a power to a power. Okay, if we were to write this out in that multiplication form, expanded out form, we have, what does this power of 2 mean we're going to do with the base of 4 cubed? Following what we did right here, just the definition of an exponent. A power does what to the base? Power represents repeated multiplication of the base. So if we take this base of 4 cubed to the power of 2, we're going to multiply 4 cubed by itself how many times? Twice. So we get 4 cubed times 4 cubed. Well, each of these 4 cubes is an exponent also. And so in each of those, you're going to take your base and multiply it by itself how many times? 3. So we're going to take this times this. Okay, in which, if we added these up, we have 3 plus another 3. So we get a power, or a base of 4 and a power of 6. So you could expand it out to get 6, or you can use a shortcut. What can we do to these original numbers to get to this new power of 6? Yeah, you can multiply them. So the power of a power rule says that if you have an exponent taken to another power, you can keep your same base. All you have to do is multiply the powers. Okay, so if you did something like this, 6 cubed to the 4th, you can simplify this by taking your common base, 6, and you're going to take it to what power? The power to a power, you multiply. So we're going to take 3 times 4, we get 6 to the 12. And once again, this works with negative numbers. It also works with variables. And so if I took z to the 4th all to the 5th, what's that going to simplify into? Common base. 4 times 5 gives you 20 as your power.
On the first one, did you mean 4 to the 5th accidentally? Or did you mean...
On this one here?
Oh, I know. 4 to the 5th.
On this one? Yeah, because you're going to the shortcut is to multiply the powers. So 3 times 2 would give you the 6th. Okay. So the general rule for this is a to the m all to the n. If you take a power to a power, you're going to multiply those powers. And this is power of a power is the terminology used to describe that relationship.